Today we are going to discuss measurement shortcuts. Total measurements will covered in 10 minutes only. You have almost solved all questions in examination with shortcuts. Let's start first shortcut. This is first shortcut number 1, right? Measurement of power by using 2 wattmeter method. How we can measure by 2 wattmeter? In general exam they are asked 2 wattmeters are given, right? W1 and W2. This is the load R, Y, B. So if 2 wattmeters are read same value, then what is the power factor of the load? Since if 2 wattmeters are read same value, then what is the angle? Phase angle is 0 degrees. Substitute 5 0 degrees. If 2 wattmeter is, one of the wattmeter is twice the second wattmeters, one of the wattmeter is twice the second wattmeter, then 5 is 30 degrees plus 30 degrees. Same as this, if one of the wattmeters is read 0 reading, then the angle is 60 degrees, then cos 60. So this is the simple question. Next shortcut number 2 is, this is measurement of resistance. Measurement of resistance. What is this? PAK was dim. PAK was dim. PAK was dim. Right? This is low. This is medium. This is high. This is low resistance measuring instrument. This is medium resistance measuring instrument. This is high resistance measuring instrument. P means potential voltmeter method. Ammeter voltmeter method. Kelvin's double bridge meter, right? Potential ammeter voltmeter, Kelvin's double bridge. It is a very important. What was W1, Watson bridge, Ohm's bridge, substitution bridge. This is loss of discharge. This is mega. This is mega ohm. That's all. One more thing is 423 terminals. What is this HV? Let's discuss about HV. HV means HV. We know voltmeter, ammeter. Voltmeter, ammeter. If for suppose first is voltmeter, then ammeter, what is this resistance? Load resistance is how much? Simple. HV. If first is voltmeter, then resistance is high, RH. High resistance. Voltmeter, ammeter, high resistance means low load current. But if it is ammeter and then voltmeter, it is low resistance means high load current. MMC instrument, which is used DC value, average value. Shortcut is Bunny. Deflection torque is Bunny. BANI. Torque by weight use is high. K. What is the N is equal to K? N means revolutions, right? Revolutions. K is constant. What is constant? Revolutions per kWh. Revolutions per kWh. What is E? E means energy. VI cos phi into time. That's all. Out of these 3 parameters, in exam, 1 parameters will be unknown. Remaining parameters will be given. For example, let's take one. Suppose 200. What is K? 200K means what? 200 revolutions per kWh is given. Applied 230 volts with 10 amps unity power factor up to 3 hours to the energy meter. Then what is the total revolutions made by the disk? That is the question. So how can solve? Simple. We can substitute over this all items to the here. For example, 200 into, what is the energy formula? VI cos phi. 230 into 10 into UPF1 into 3 hours by 1000. It's come with RPH. Sorry. If we need in meters, minutes, since we can substitute by 60, means here I had 60, then we can obtain this is in RPM. For example number 2. For example, they give 1940 as a revolutions made by the disk in energy meter. So applied voltage is 230, 5 amps current will be 4. What is the power factor if it is run 5 hours? Then simple. E is equal to N by K. What is the N? 1940. What is the K? K is already given now. K is here, sorry. K is 400. 400 revolutions per kWh. Here 400. We obtain E. Then what is meant by E? VI cos phi into T. VI cos phi into T by 1000, right? Here we are having 230 I having 5, we need power factor. What is time? 5 hours. Simple, we can obtain power factor by simply solving this one. Next we are going to the shortcut number 5. Shortcut number 5, that is bridges. How we can solve by simple, we can first of all remain this one 143 you know guys, right? 1432 MHOA, right? MHOA 1432, right? I can explain this one simple man, simply I can explain this one very simple, right? So this is a bridge. So this is a bridge Z1, Z3, Z2 and Z4. This is a common bridge we can use it for all. This is the galvanic. So next what I am saying 1 4 3 2 M H O A. This is the shortcut I am going to tell you. Simple thing, we have to Z1, Z4, Z3, Z2. This is Z1, Z4, Z3, Z2. Now R1, L1 only. Here C4, R4 only. Total is over. Here R3, total R3, 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 R3. Here total R2, 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 R2. Here R1 plus L1. Simple. R1 plus L1, R1 plus L1, R1 plus L1 plus Anderson bridge R. Here R is come here. Next here C4 parallel with R1, C4 plus R4, C4 again here R4. That's all. This is the known as all bridges. And one more important thing is MHOA, right? It is a high Q, high quality factor. It is a M for medium quality factor. O for Own's bridge, wide range of quality factor. Ultimately it is the low quality factor. Percentage guarantee accuracy error. This formula is limiting error by full scale value into 100. Next, percentage limiting error is limiting error by true value into 100. So we can expect one question from these formulas. How can solve simple method? So, for suppose in instrument they given accuracy as 1%. 1% accuracy given as 1%, that is 5 and full scale value is 100 amps, per suppose 100 amps. Then find the percentage limiting error how much for measurement of true value like 50 amps. So we can find, how can we can find? By using this formula. So limiting for an instrument, limiting error and accuracy means percentage guarantee accuracy was not change for any value of the true value and measure value. So hence from this we can obtain here accuracy is 1%, limiting error and full scale value is 100 into 100. From this we can obtain limiting error. Substitute this limiting error into here this formula, that is percentage limiting error. This limiting error, how much true value measure value? 50 into 100. Then we can find the percentage limiting error. This is important guys. Next one is simple. Here plus divided into divided add percentage, right? Plus minus add magnitude. What is this? For suppose they given power cos phi is equal to W by VI. So if we can find, suppose W is, they are giving 555 plus or minus 2%, right? V is equal to 220 plus or minus 1%. Suppose they are giving values like this, I is equal 5 plus or minus 1%. How can calculate this one? By using this one, simple. So we know that 550 into 220 into 5. Oh, complete हो गया. Next here what I am saying initially, for plus minus add magnitude, for multiplication and dividing add percentage. Here these all are the dividing, 2 divided by these 2. Here these 2 are multiplying, since percentage we can add, right? Means 2 plus 1 plus 1, simple. For suppose this is in magnitude 5 plus or minus 2, then we can convert to in terms of percentage potence formulas are these two. These are extension of given instrument RSH, RSC, Rm by m minus 1, Rm into m minus 1. Rm means given meter resistance. Here also given meter resistance. M means if per suppose existing meter is only designing for 5 amps, I want to measure 500 amps by using this measurement. So what we can do, we can extension the range of meter by using this formula. M means multiplication factor. M means almost simple 1 by 2 formula you can use, right? Here 500 divided by 500, so M is 100. Here range is 100 for ammeter. Ammeter nothing but RSH. Voltmeter RSC. For in ammeter we using RSH means shunt resistance. In voltmeter we using series resistance. It is low value, it is high value of resistance. High value of resistance, low value of resistance. Right. Next LPF wattmeter. LPF wattmeter, only one point, that is CC. CC means current coil in wattmeter, current coil in wattmeter, and compensating coil and pressure coil. So lot of times asked that how we can connect compensation coil in LPF wattmeter. Simple, we can connect it in series. We can connect it series opposite to the pressure coil. This compensating coil connected in series opposite to the pressure coil. This compensating coil connected series opposite to the pressure coil.